Validating the number of threads in new. We'll continue to get warnings because we aren't doing anything with the parameters to new and execute. Let's implement the bodies of these functions with the behavior we want. To start, let's think about new. Earlier, we chose an unsigned type for the size parameter because a pool with a negative number of threads makes no sense. However, a pool with 0 threads also makes no sense, yet 0 is a perfectly valid usize. We'll add code to check that size is greater than 0 before we return a thread pool instance, and have the program panic if it receives a 0 by using an assert macro, as shown in listing 20-13. Okay? So in summary, we already noted that having a negative number for the number of threads that we want to have in our pool is asinine, or it just doesn't make sense. But passing in 0, which is a valid usize, also doesn't make sense. But since that's a valid usize, we need to add code to protect against it. And that is this assert. And assert, if I recall correctly, throws a panic if it's not adhered to. And we should probably document that in our documentation because this can throw a panic and the user's not going to know that. That should be documented. But anyway, let's go back to our code and add this one line. We've added some documentation. Oh, they did add documentation. It's right here. I completely missed that. It's inline documentation. What? Make that look pretty cool. And the documentation states, we create a new thread pool. The size is the number of threads in the pool. Panics, so the panic is documented. The new function will panic if the size is 0. Oh, so they did everything I said they should do. Good to know. We've added some documentation for our thread pool with doc comments. Note that we follow good documentation practices by adding a section that calls out the situation in which our function can panic, as discussed in chapter 14. Try running cargo doc -open and click the thread pool struct to see what the generated doc for new looks like. That sounds like I should do that now. And I don't want to type it there. I want to type it here. Cargo doc open. And open, I think, opens the page automatically in your default browser, which is this one. And here, oh, that looks kind of professional. Here's new. Here's what I just wrote. Here's the panic section. And here's the statement. Yeah, that looks good. That looks really good. Instead of adding the assert macro as we've done here, we could make new return a result like we did in config new in the IO project listing 12-9. But we've decided in this case that trying to create a thread pool without any threads should be an unrecoverable error. If you're feeling ambitious, try to write a version of new with the following signature to compare both versions. Alright, so basically what they're stating here is that there are other ways of doing this if we wanted to. Instead of throwing a panic, we could do a result, which is what we did in the IO project. However, their argument for making this unrecoverable, as in having a panic instead of result, does make sense. If you pass in 0 as you want 0 threads in your pool, that doesn't make sense at all, and that should be unrecoverable. So I agree with their decision. And this wouldn't be hard to implement, the result part, but it doesn't seem worthwhile. Creating space to store the threads. Now that we have a way to know we have a valid number of threads to store in the pool, we can create those threads and store them in the thread pool struct before returning it. But how do we store a thread? let's take another look at the thread spawn signature. They have a join handle. Spawn, we looked at the F. The T was just whatever is being passed in. I think we can still ignore the T. Join handle, that's probably it. The spawn functionality returns a join handle, T, where T is the type that the signature returns. Let's try using join handle 2 and see what happens. In our case, the closure we're passing to the thread pool will handle the connection and not return anything. So T will be the unit type. Parentheses. The code enlisting 20-14 will compile but doesn't create any threads yet. We've changed the definition of thread pool to hold a vector of thread join handles with the unit thing instances. Initialize the vector with a capacity of size. Set up a for loop that will run some code to create the threads and return a thread pool instance containing them. Yeah, let's read through that real quick. So I'm not exactly sure what join handle does, but I guess we're going to find out shortly. That was the only thing that was in spawn, right? That we didn't really cover. And T is just the thing that they return, that the closer returns. But in our case, it's just an empty unit. So we can ignore T. And as they stated, thread pool has threads, which is a vector of thread joins. And in new, we're creating a vector with the capacity of usize, or with size, which is going to be 4 in our case. And then for underscore, because we're ignoring the numbers, but from 0 to size, so that's to be 0, 1, 2, and 3, not including 4. We're gonna we should be storing a thread spawn in the vector. At least that would make sense to me. I'm not exactly sure how we're gonna do it, but and then here we return the thread pool and the threads. Oh, wait. I guess we'll be initializing threads and then storing them. Or setting it. We'll see. Oh, but this code needs to be put into my editor. So this is, I can just replace new. Yeah. Yeah, the search still there. We've brought standard thread into scope in the library crate because we're using thread. Did they? Oh, yeah, I forgot about that. Thread is not in scope. Use standard library thread. We brought standard thread into scope in the library crate because we're using thread join handle as the type of items in the vector in thread pool. Once a valid size is received, our thread pool creates a new vector that can hold size items. We haven't used the with capacity function in this book yet, which performs the same task as vec_new but with an important difference. It pre-allocates space to the vector. Because we know we need to store size elements in the vector, doing this allocation up front is slightly more efficient than using vec_new, which resizes itself as elements are inserted. When you run cargo check again, you'll get a few more warnings, but it should succeed. Yeah, they still haven't explained join handles, which, if I had to guess, it's just being able to act on the different threads, like to join them to the main thread or another thread, and mainly so you can get the results back, because a thread executes in a new process, right? And then once that finishes, in order to be able to know how that thread ended, it needs to be able to join back into the process that called it, its parent process, and give you the result. So I'm pretty sure that's what join handle does, but don't quote me on that. They went over with capacity, which makes sense. We're allocating the predetermined size of the vector where it's going to start. And that's all they really did here. But they said that we can use cargo check to see our errors, which should just be warnings, and everything else should compile. It should compile just with warnings. And that is not true. My standard library import is correct. It's just not used. But threads is actually an error because threads isn't allocated or defined any. Wait, no, it's right there, mutable threads. So why are you giving me an error? Thread pool does not have this field. I forgot to add this field. I forgot to add this line. And that is here. I guess I don't need that. And now when I do cargo check, it compiled. So yeah, I forgot to add this line. My bad. A worker struct responsible for sending code from the thread pool to a thread. We left a comment in the for loop in listing 20-14 regarding the creation of threads. Here we'll look at how we actually create threads. The standard library provides thread spawn as a way to create threads, and thread spawn expects to get some code the thread should run as soon as the thread is created. However, in our case, we want to create the threads and have them wait for code that we'll send later. The standard library implementation of threads doesn't include any way to do that. We have to implement it manually. The setting up the line of work in this paragraph, which basically is stating before we're using thread spawn, the way thread spawn works, you give it the code it's going to run, and thread spawn is going to handle the creation of the thread for you and then immediately run that code. However, in our case, we want to create a thread, have it sit around for a bit, and then eventually send the code. Since we're having it sit around for a bit, since we're creating it and having it sit around for a bit, that we can't use thread spawn directly, seemingly. And the standard library doesn't implement this for us, so it looks like we're going to have to implement it manually, at least based on what they're stating here. We'll implement this behavior by introducing a new data structure between the thread pool and the threads that will manage this new behavior. We'll call this data structure worker, which is a common term for pooling implementations. Think of people working in the kitchen at a restaurant. The workers wait until orders come in from customers, and then they're responsible for taking those orders and filling them. All right. Instead of storing a vector of join handle instances in the thread pool, we'll store instances of worker struct. Each worker will store a single join handle instance. Then we'll implement a method on worker that will take a closure of code to run and send it to the already running thread for execution. We'll also give each worker an ID so we can distinguish between the different workers in the pool when logging or debugging. Alright, so we read these two paragraphs. And in summary here is we can't use join handles directly in our vector. Instead, we need to have an intermediate data structure called, well, we called it worker, which is a common term in pooling implementations, as they stated right here. But yeah, the worker is actually going to run or be in charge of the take closure in run thread part of our thread pool stuff. And then we're going to give the worker different IDs so that when we do logging or debugging, we know which worker is doing what, which we can track where the workers work. Let's make the following changes to what happens when we create a thread pool. We'll implement the code that sends the closure to the thread after we have worker set up this way. 1. Define a worker struct that holds an ID and a join handle. 2. Change thread pool to hold a vector of worker instances. 3. Define a worker new function that takes an ID number and returns a worker instance that holds the ID and a thread spawned with an empty closure. Not sure if I understood that one. 4. In thread pool new, use the for loop counter to generate an ID, create a new worker with that ID, and store the worker in the vector. Okay, so we're doing these 4 things, which is we're creating the worker struct, we're adding it to our thread pool definition with threads, where we had was vector of join handles. Now it's going to be vector of workers. In worker new, we're going to have that initialized with an ID number, which is going to be created from the for loop, and it's going to return a worker instance that holds the ID and a thread spawn with an empty closure. I'm not sure about the empty closure part. And then the last part was kind of went over it. The for loop is going to generate the workers and put them into the vector. But yeah, so that's what we should be seeing down here. Oh, if you're up for a challenge, try implementing these changes on your own before looking at the code and listing 20.15. Thank you for the suggestion. I'll pass. Ready? Here's the code. And let's look down here. Thread. Oh, I did it again. I did not mean to do that. All right, here's the code. Thread. We change this to workers and vector of worker. Let's look at worker first. Workers down here has a ID, which is use size, and thread, which is thread.join handle, so just a single one. Implementation for worker, new, takes use size. Let thread spawn, and it just has an empty closure, which they did mention, and just going to return that as the worker. Okay? Coming to new, or thread pool, implementation for thread pool, we have the new. It's going to return a thread pool. We're going to make sure that the size that's passed in is greater than 0. We're going to create a mutable vector that has the correct size associated with it, like pre-allocated slots. And then for ID, which is just going to be the number 0 to, I guess, 3 in this case, we're going to workers, which is the vector, dot push, which is going to add something to the vector, and we're creating a new worker. So worker, new ID. And then we're returning thread pool and workers. One thing to note here is that no, we still have the execute. We just haven't changed it. The execute is not in the snippet. Yeah, we should be good. Let's put this in our editor. Move this to the side. Open this up. So let's start from the top because I don't want to miss this again. You are now workers. New has been changed a lot. And then this is all new. This is the work implementation. Struct then the implementation block. It's gonna be added to the end. Cool. And just because I'm curious, cargo check. It compiled. There are warnings, but it compiled. There are a number of warnings. Ugh. We changed the name of the field on thread pool from threads to workers because it's now holding worker instances instead of join handle instances. We use the counter in the for loop as an argument to worker new, and we store each new worker in the vector named workers. Yes, correct. External code, like our server in the main file, doesn't need to know the implementation details regarding using a worker struct within thread pool. So we make the worker struct and its new function private. The worker new function uses the ID we give it and stores a join handle instance that is created by spawning a new thread using an empty closure. This is true. I did not note that the worker was private, but that makes sense given that external code doesn't need to know about this worker because the worker is just an internal detail of the thread pool. It should be private. Yes, I agree. This code will compile and will store the number of worker instances we specified as an argument to thread pool new, but we're still not processing the closure that we get in execute. Let's look at how to do that next.